Next, chapter 7, frequency response analysis, 6th semester electrical, subject control system engineering. Name of the chapter resonant frequency domain analysis. I am Arun Ranjan Naik, HOD Electrical Nilachal Polytechnic, representing the rest part of the frequency response analysis. Resonant peak in frequency response corresponds to the peak overshoot in the time domain transient response for certain values of damping ratio del. So the resonant peak and peak overshoot are correlated to each other. Bandwidth. It is the range of frequencies over which the magnitude of Tj omega drops to 70.7% from its zero frequency values. At omega is equal to 0, the values of u will be 0. Substitute u is equal to 0 in m is equal to 1 by square root of 1 minus 0 square plus 2 xi 0 square, that is equal to 1. Therefore, the magnitude of Tj omega is 1 at omega is equal to 0. At 3 decibel frequencies, the magnitude of Tj omega will be 70.7% of magnitude of Tj omega at omega is equal to 0. At omega is equal to omega b, m is equal to 0.707 into 1, that is equal to 1 by root 2. So m is equal to 1 by root 2 is equal to 1 by square root of 1 minus ub square root whole square plus 2 xi ub square, that is equal to 2 is equal to 1 minus ub square whole square plus 2 xi square into ub square. Let ub square is equal to infinite, that implies 2 is equal to 1 minus x square plus 2 xi square whole square into x. That implies x square plus 4 xi square minus 2 x minus 1 is equal to 0. That implies x is equal to minus 4 del square minus 2 plus or minus 4 del square minus 2 square plus 4 by 2. Here we are applying the formula b square minus b plus minus b square minus 4ac root over divided by 2a, where a is equal to 1 here, b is equal to 4 del square minus 2 and c is equal to 1. So we can consider only the positive value of x is equal to 1 minus 2 xi square plus 2 xi square minus 1 square plus 1 square root. That implies x is equal to 1 minus 2 xi square plus square root of 2 minus 4 del square plus 4 del to the power 4. Substitute x is equal to ub square is equal to omega b square by omega n square. That implies omega b square by omega n square is equal to 1 minus 2 del square plus square root of 2 minus 4 xi square plus 4 xi to the power 4. That implies omega b is equal to omega n square root of 1 minus 2 del square plus square root of 2 minus 4 del square plus 4 del to the power 4. Bandwidth omega b in the frequency response is inversely proportional to the rise time tr in the time domain transient response. The Bode plot. The Bode plot or the Bode diagram consists of two plots. First one is magnitude plot, second one is phase plot. In both the plots, x-axis represents angular frequency in logarithmic scale, whereas y-axis represents the magnitude linear scale of open loop transfer function in the magnitude plot, and the phase angle linear scale of the open loop transfer function in the phase plot. The magnitude of open loop transfer function in decibel is m is equal to 20 log magnitude of gj omega hj omega. The phase angle of the open loop transfer functions in degree is phi is equal to angle of Gj omega Hj omega. The basic of Bode plot. The following table shows the slope, magnitude and phase angle values of the terms present in the open loop transfer functions. This data is useful while drawing the Bode plot. This table represents the type of the term Gj omega Hj omega, slope d decibel per dB per dec, magnitude in decibel, phase angle in degree. So terms type of constant, first one is constant k and slope is 0, magnitude 20 log k, angle is 0 degree. At 0 at origin, Gj omega Hj omega is j omega, slope d by dc 20, magnitude dB 20 log omega, phase angle is 90 degree. N zeros at origin, j omega to the power n 20n log omega 90n. The pole at origin 1 by j omega, slope minus 20 log omega minus 90 or 270. N poles at origin 1 by j omega to the power n minus 20n log omega minus 90n plus 270n. Simple 0 Gj omega H omega value is 1 plus j omega r, slope dB by dc 20, magnitude in dB 0 for omega less than omega r, 20 log omega r for omega greater than 1 by r. So phase angle is 0 for omega less than 1 by r, 90 for omega greater than 1 by r. Simple pole 1 by 1 plus j omega r is equal to minus 20 and 0 for omega less than omega r, minus 20 log omega r for omega greater than 1 by r. 0 for omega less than 1 by r, minus 20 or 270 for omega greater than 1 by r. Second order derivative terms omega n square whole into 1 minus omega square by omega n square plus 2z del omega by omega n 40 log omega n for omega less than omega n, 20 log 2j omega n square for omega is equal to omega n. Then 40 log omega for omega greater than omega n, angle is 0 for omega less than omega n, angle is 90 degree for omega is equal to omega n, angle is 180 degree for omega greater than omega n. Second order integral term 1 by omega n square whole into 1 minus omega square by 1 omega n square plus 2 del omega by omega n. So the value is minus 40, the angle is minus 40 log omega n, mod is magnitude is minus 40 log omega n for omega less than omega n, minus 20 log 2j omega n square plus omega is equal to omega n, minus 40 log omega for omega greater than omega n. So angle is minus 0 for omega less than omega n, angle is minus 90 for omega is equal to omega n, angle is minus 180 for omega greater than omega n. Consider the open loop transfer functions GSHS is equal to K. Magnitude M is equal to 20 log K dB. Phase angle phi is equal to 0 degree. If K is equal to 1, then magnitude is 0 decibel. If K is greater than 1, then magnitude will be positive. If K is less than 1, the magnitude will be negative. The following figure shows the corresponding Bode plot. M dB versus log omega. This is K greater than 1, then 20 log K line is this one. K is equal to 1, the line is we consider the 0. So this one is minus 20 log K line where K is greater than 0 but less than 1. This one is the angle of phasor diagram of the Bode plot that is drawn between phi in phase angle phi in degree versus log omega, and this one is the x-axis line where log omega represents, this one is y-axis line where angle phi in degree. So this one is the line for which K is less than 0 and K is greater than 0 and less than infinity. That shows the phase angle diagram.